Hello and welcome to The Building Envelope, Innovations in Planning, Materials and Budgets, a special webcast presented by Building Green. My name is Tristan Roberts, Editorial Director for Building Green. I'm going to introduce our speakers in a moment, but first I'm going to do a little housekeeping. You should be getting both audio and visuals through your computer. If you have any technical issues, just post them to the chat window. There will be a Q&A at the end. Please post your questions at any time during the presentation to the chat window. And now I'm really happy to introduce today's speakers. For more than 30 years, Alex Wilson has been the most trusted voice on energy efficiency and environmentally responsible design and construction. The founder of Building Green, he launched Environmental Building News in 1992, later followed by GreenSpec, BuildingGreen.com, and LeadUser.com, trusted resources used by tens of thousands of green building professionals today. More recently, Alex founded the Resilient Design Institute and undertook the complete overhaul of a Vermont farm, which he'll discuss in part today. We're also here with Eli Gould. Eli earned a joint degree at Yale University in Architecture and Environmental Studies. After returning home to Vermont, he founded the vertically integrated company Ironwood Brand, combining native lumber, high-performance prefab, and advanced mechanical systems. The company has branched into the dedicated new lines known as Precraft Inc., manufacturing, Sticks, L3C Forest Products, and Eli, I'm not quite sure how you say that one.
Yeah, V-Chip.
V-Chip, modular mechanical rooms. In recent years, he has built some of the highest performing residential buildings in the region. So now, Alex and Eli, take it away.
Thank you, Tristan, and it's great to be here. I don't know what the weather's like where listeners are, but it's drizzling in Vermont, but good for the gardens. Eli?
Yeah, thanks for showing up, everybody. We really look forward to sharing this project. It's been a big part of our life for the past year and a half.
Yeah, so we set out, my wife and I bought a farm 2.5 years ago and began thinking about what this house could be for us and the property. We set some pretty tough goals. We wanted it to be net zero energy. We wanted to avoid fossil fuel use on the premises. Durability was a big issue for us. We challenged the designers, Eli and other team members, to come up with a building that would last 300 years. We wanted a very low maintenance house, a house that my wife and I could age in. I've written a lot over the years about foam plastic insulation, and I wanted to try out some of the alternatives to foam plastic that don't have flame retardants and other chemicals that we don't like to add to the environment. So, it was an opportunity to put my money where my mouth has been and try out some of these, in some cases, unusual or even weird products.
Yeah, and from my point of view, as I came onto this job, having had a little bit of a track record in doing some one-of-a-kind things, I really felt like my passion for green building, to move forward, ultimately, we needed to get ways that were more systematic, we needed to get more affordable, and I felt like there was opportunities all over this project to trial and demonstrate that. And one of the big ways was to engage with some of the manufacturers themselves who were really interested in seeing what Alex would do and what Building Green would recommend and what we would trial, and seeing if there were new paths to market that were not as expensive and slow and as uncoordinated as we often see. So, I bring a prefab mindset, and when I'm doing something, even if it was something that was hard, tricky, we're doing it for the first time, we and the guys in my shop are always thinking, how can we pre-craft this? How can we make this a shop-built thing so that we can really drive keep the quality up and drive the cost down? But then, of course, as this was a very human project with some great humans all around us, we really wanted to respect the long history of this house and the farm. It had been there for 200 years plus, and wanted to, there's not a lot of chances to really let that happen all over again with a whole rework. And to also, even though we knew from the start we had some big far-reaching goals and people who were going to really raise the bar high, we really just wanted to succeed at this project, even if we couldn't do everything to a perfect level. We needed to get this house right.
So a lot of planning went into it. John Abrams, who's standing up in this photo, a builder from Martha's Vineyard and a very good friend of ours, looked over our shoulders, and we had a planning charrette. That's Mark Rosenbaum, a highly respected energy engineer in the red shirt, chatting about ideas in an early charrette we held at our old house to talk about this new property.
Yeah, and one of the things that we brought in, even though we're going to see a lot of traditional architecture and naturally derived materials here, from my own background, I bring in a 3D CAD/CAM platform that really not only runs a lot of the larger automated shops, but also a lot of Swiss timber frame companies. And it's a really capable enough platform. In this picture, just kind of a montage, you see some of the various things that we used it for. Everything from doing prefab new dormers to actually measuring the old historical frame that was left inside the walls to see what the framing factor would be. So we had one central model for this whole project. Every plan and every section which was cut came from that model, and in many ways, even though it's not a featured part of this project, it is one of the modern tools that makes it possible to tackle this kind of complexity.
And as a client, it was awesome to be able to work with this 3D program and with Eli, zoom in through a window and look at what the interior would look like as we reconfigured the floor plan and put the stairs up to the second floor in the center of the building instead of at the north end where it had been. So it's an amazing tool. I don't know the specifics of it, but really nice resource that we used. We did move the house a little bit. We had an early decision to make whether we were going to keep the existing foundation and kind of deal with it with, typically spray foam insulation, spray polyurethane foam, most commonly used for insulating basement foundations, or if we could actually build a whole new foundation. And we made that call early on to go ahead and put in a new basement to be able to insulate it right, to deal with the moisture issues correctly, and really have a house we could be confident in for, on into the future. Then deciding to build a new foundation, the question was, do we raise up the house in place and build underneath it, excavate underneath it and put in a foundation? Or Eli suggested we think about actually picking up the house and moving it out of the way using a big crane. And I'll let Eli talk a little bit more about that. But
yeah, but actually, we're going to see pictures, but in reference to the site plan here, there were a couple things going on the site in which it wasn't really at a solar optimum. It was right under a big, beautiful heritage maple tree. It was a little close to the road itself, and the opportunity to pick, which we're going to look at, did also let us do things like swing it to a line with our perfectly aligned barn, move it back from the trees, and also move it back from the house, all of which would have been really tricky using conventional means. And it actually was something that we envisioned as a predictable and cost-saving thing, and once we got underground, we realized that had definitely been the case, but we'll see some pictures about that now.
So here's the house as it was. The house had not been occupied for about 10 years. It had the basic original footprint, sort of to the right and in the back, a square about, I think, 29 feet by 30 feet, so fairly compact. There was a kitchen addition that was put on at some point back in the early 1900s, and then a series of sheds onto that. Actually, one of those sheds may have been the original house. We think the frame predates the frame of the house, which was likely built in the early 1800s. We did some demolition. Here we see the kitchen being taken down. The frame on the right we maintained and moved that to elsewhere on the property as an equipment shed. generated a little more waste than we would have liked, but the wood was in pretty poor shape. Very little of it was salvageable. We did salvage timbers that we were able to reuse and as much wood as possible and other materials, but I cringe at the fact that a fair amount did go to the landfill. This is an interior shot after we stripped off the plaster. It's kind of an interesting structural system. Maybe Eli can talk a little bit about this.
I could speak to this a little. This was my thesis study area, and it was a little bit of a gray area. Alex had lived for years in a really beautiful timber frame up the road, and in the early 1800s when this was done, there was really not a lot of trees left, and there was a tradition of timber framing that had really hybridized up to our area, which is north of both the Dutch and the English settlements. So you see things here that are a mix. People have been doing things for 100 years, almost like stick framing in some cases, not quite beautiful in others. Some interest in the sense of there was a bearing wall up the middle, which had been formed by these wide planks that you can see from the horizontal lines were actually still the old up and down water-driven mills. So a lot of interesting features, but really a little bit of a gray area. As we stripped it out, we were hopeful that maybe we would find something so beautiful that it would just be shown to the inside and that we would super insulate on the outside, but we had to go into some grayer area after that. I'm going to speak to my engineering mentor here, Ben Brungraber. He's one of the top timber engineers in the nation, and I love this picture because it shows all the human factors at work here. And when I told Ben, I really thought that I shouldn't, be jacking and cribbing under this, that I should just pick it out of the way. Alex caught that moment, and I also especially love my worker behind me who had been systematically taking out what we ended up with about 13,000 pounds of horsehair plaster. He was looking at me like, what are we going to be getting into next? So this is definitely a case of a whole bunch of people putting our heads together for the right thing to do.
Okay, so here's the house move. We were fortunate. There's a company in Vernon, Vermont, just south of Brattleboro Valley Crane that has a very large wheeled crane, and they came over to pick up the house. We had some advantages we could achieve in doing that Eli can speak to in providing more headroom.
Yeah, and we may see that better on the next slide actually, but we really felt as if there's multiple things in this picture that kind of illustrate what we were aiming to do. Number one, we picked it from the upstairs floor, so those slings go right in through the second floor. The triangle, the roof itself is really strong in that case, and even though the house was really not level all over, we knew that it had been built level. So when we cut it free, we measured down from the top plates as if it was going to straighten out, and as soon as it was picked, it instantly straightened out. We then added a large 12-inch LVL rim joist that went right around all those studs, and we actually elevated the finished ceiling height. In the original house, the ceilings were just probably not even 8 feet, and the window head heights were low. Alex and Geraldine and all of us really wanted to see natural light going deep into this building, so we made that choice from the start as a pick strategy, and we also were able to use that rim to let modern services run around in a baseboard chase without having to drill through all the old timber elements. So a largely successful strategy. We knew that the first floor deck was really not worth saving or putting a lot of manual labor into. And though I really had a lot of great review for this strategy, both from my engineer and my previous experience and my crane company, you might see closely I'm actually sweating a little at this moment, but we got it done.
Yeah, so then foundation work began, and with this we ended up being really glad that we had picked up the house to move it out of the way. Had we done a more conventional plan of just jacking it up in place, it turns out the house was sitting on about 8 or 10 feet of pretty pure sand, and it was tough to contain those walls. They wanted to cave in So we were glad to have the house out of the way so that we could build that foundation, the excavation out wider. Here you see forms going in for the footings. And interestingly, on the footing pour, we worked with a local concrete contractor and used a capillary break on the footing between the footing and the concrete pour for the walls. And that contractor hadn't worked with a capillary break before, but by the end of the project, when he stopped back to do an additional pour, he'd already recommended it to another client, and they had used it on a project. So we've had an effect influencing the local building industry to some extent.
Not only that, but I think he's actually doing it all the time now, and I think he's being asked to do it a lot more, maybe because it was the topic of an article, or maybe it's just a general trend now. But
we're not going to really cover this in this presentation. We will in a future presentation, but you can see our barn in the background. That's an 1812 barn with a south-facing roof, due south, which now holds a photovoltaic array. Okay, the concrete pour, nothing too special about that. Forms removed. And now we'll get into some of the innovative materials we used in the house envelope. And I will be talking about other non-envelope related building products in a future webcast. So keep an eye out for that, some of the finished materials we used in the house. But I mentioned at the outset that I wanted to avoid conventional foam plastic insulation to the extent possible. The vast majority of foundations today go in with extruded polystyrene, or XPS, and that's a material that contains a brominated flame retardant that's now being phased out internationally. It also contains a blowing agent that is a greenhouse gas, a very potent greenhouse gas. So we wanted to try out something different, and I've written about various alternatives. This is a foam glass product. It's made by Pittsburgh Corning, and it's a foamed glass. It's been made since the 1930s. It's got very good compressive strength, so we knew that it would be good under a concrete slab. But it hadn't been used much in that application, at least in this country. It's more commonly used in Europe. In this country, the primary application for foam glass is industrial applications. It's very high temperature resistance. It means that it works for steam pipes, for very high temperature process heat issues. It is more expensive than XPS, typically 2.5 times the cost, and the R value is somewhat lower. It's 3.4 per inch. But again, I wanted to try out alternatives so that we could at least be talking about them with some experience behind it. We used 4 inches of foam glass under the slab, and then 6 inches on the foundation walls. For the sub-slab, as you can see, let me go back to that, we just dry laid them. There's a 4-inch layer of crushed stone, filter fabric, 1 inch of sand for leveling, and then the dry laid foam glass. We didn't need an adhesive of any kind, but for the walls we did, and this led to a really interesting debate we had and discussions with the manufacturer. We had gotten a really good price on the foam glass, and then I wanted to glue it on and said, well, what are the options? And Pittsburgh Corning said, well, we have 2 different materials we sell. What we really recommend is this solvent-based product that really does a great job. Problem is it's fairly expensive, and I think it was going to add $3,500 to the project cost. And I asked for the material safety data sheet and got that and looked at it. And I've read a lot of MSD sheets in my days, and this was one of the most toxic materials I think I'd ever seen. It was a naphthalene base with 4 different kinds of isocyanate in it. Isocyanates are being looked at very carefully by EPA today for their toxicity. And we didn't want to go that route. So I talked to Pittsburgh Corning. They said, well, we've got a greener material, a zero VOC acrylic adhesive. I talked to someone who used it and actually had some problems with it. And, you know, we're still looking for other alternatives. And fortunately, Eli is as much a researcher as I am, and started talking with friends of his in the masonry industry.
Yeah, and you know, I've watched as polymer cements have really changed the nature of building over the last, you know, generation, in that we're now hanging facades on skyscrapers and doing all kinds of things. And even in our own practice, we use polymer cement to stick stone veneers to buildings, and they survive freeze thaw. And it's a relatively benign material, and it certainly has strength. And we had already made a lot of really safe moves on this building in that we had a wide footing. We were going to be stacking these like a brick anyway. So I really felt like it was time to show the manufacturers out there what we were trying to do, make sure Alex and I weren't forced to use a really toxic product, and really encourage them to develop a system. So we, my son and I actually bought a whole bunch of different cementitious products and did a whole bunch of trials on the foam glass. And we settled first on a polymer cement adhesive called X5 to stick them to the walls themselves. And we also made some choices. You'll notice in the photo here that we decided not to tar and waterproof the foundation itself, because that would really not help the cement to cement bond we were looking to make. So we only, the black spots you see are really only sealing up where the wall ties went through the forms. And then we called both the manufacturers to say what we were going to try and do. And it turned out both of them were from Pittsburgh, Pennsylvania, and the Ardex manufacturer was so interested in it that they sent out a senior product representative who had years of masonry experience. He jumped right into the ditch with us and helped us go from there. You see also that since we had decided that we were going to waterproof the outside, Alex will talk some more in detail about that. Even though foam glass is a very impermeable thing itself, we were really trying to make sure that it didn't get a lot of moisture that then had freeze thaw and sun action on it. So we used a secondary product that was also from Ardex that was a really fine Portland with a polypropylene mesh that we embedded, and that went over the top. Alex could talk a little bit more about the technical details, and then I'll talk a little bit more about how we mechanically fastened it.
Yeah, so back on the relationship with Ardex, we had come to them saying, gee, we'd kind of like to try this adhesive this is the adhesive, let me back up a slide, like to try this adhesive, and they were really intrigued about that because they had wanted to use their adhesive on foam glass but hadn't seen it work. So they actually sent us the material to use, and they were so pleased after we did that, and I sent them photos, that they actually said, what are you going to coat it with for the waterproofing coating on the outside? They said, we have a product, Ardecoat, that we think would work very well. It's a similar polymer cement, and they not only sent the material up, but sent a technician from Atlanta to work with us on the installation. In this photo on the left, he's the fellow in the orange shirt. He worked with Eli's crew the entire day down in the trenches. It was pretty impressive dedication, and we feel very good about the products. And since then, the two companies, Pittsburgh Corning and Ardex, have been doing some ongoing testing to see if this product combination really makes sense.
Sort of interesting to comment here too that Alex and I were, when you get big companies together, there's a lot of talk about IP and NDAs, and we were really open-handed about this. We said we're not trying to develop a system on our own or own this. We think that you guys are both making good things, good products that are not being used as a system. We think that the green building world needs a foam-free alternative for this application. We believe both of these product lines are going to be there for a long time. And why don't you come with us and join this while we take some of the risk of doing it in the field for the first time? And that became a real example that we could use to talk to many of the 15 or so other companies who ultimately joined us to also give product, system, and technical support to some of the advanced things we're going to do next.
Okay, once the foundation was done, we put the house back on it. The crane came back on site. In the first lift, they were able to determine the exact weight of the building, and on the return pick, they didn't need to bring the tractor-trailer load of counterweights, so we actually saved some money on that return trip. Setting it in place. Here we see the interior frame as we started furring out. We were going to do two things with the wall envelope. One was provide cavity fill insulation, and we wanted to address the thermal bridging through the frame and also get a little more thickness. We were aiming for between R45 and 50, creating a super insulated building that would be feasible to heat with just a very small air source heat pump. So we furred these out with 2x4s or 2x3s to end up with, I think about a 7-inch cavity.
Yeah, I'd like to speak to this a little. I mean, especially the art of compromise. We had certainly done a lot of different high-performance walls and knew how we could cut down on thermal bridging to a really high level, but saving an old frame that was made of 4x8 hardwoods really put that into perspective for us. And using the modeling software, we were actually able to assure the engineer, or at least to work to get to a framing factor that made sense. We were really trying to get to a certain mechanical system size here, and when we played with it with that much wood in the walls, it was really marginal. So we went out to a 2x8 width. You can see on that bottom plate, you can actually see how the inner stud leaves a wiring chase that can run right around the building behind. And so we knew at that point that it probably would have been cheaper to knock the whole thing over, but we decided we were going to soldier right through it and make it right. And these are the sort of things that are easy to stand back and say what's the right thing to do, but ultimately we were trying to make it the best art of compromise that we could for all the different factors that were driving it. And I'd like to also speak a little bit to not only Alex's really great threshold here of how to raise the bar on a building and have it serve for 300 years, and neither of us would mean that everything in it would need to serve for that, but my former employer and really mentor and ally, Ted Benson, was really helpful, and I think is always going to be seen as a pioneer in bringing the European concepts of open building, in which buildings are separated out by smart layers. His company, some systems, even with my help, have really their own great proprietary system for open layered assemblies. I was happy to show him my own version 2.1 here for Alex's house, which does involve a ceiling system that looks like plank on timber. We'll see more pictures of it later, but really is an access ceiling system. This is a non-thermal detail, but it just points to when you are trying to limit penetrations through an envelope, one of the most helpful things is to have an interior ceiling system that works like a light commercial ceiling, in that things can change, new wires can be run, plumbing leaks can be fixed, all without going in and out of either short life cycle things like sheetrock or out through the envelope itself. I actually probably should have spoken while we were talking about double studs about the fact that, and we're going to see some more detail on this, I'm sure, but the fact this is a wall system in which the air barrier is a key element, of course, and we have been using one sheathing company for that because of the exterior treatment on that, which we'll see more about soon. But basic concept, and a concept I feel really great about, is that there's a super thick wall with the air barrier somewhere near the middle, and it can dry completely in both directions. So we're going to come back at that from the outside, but I just wanted to speak to that a little bit too.
Yeah, and in this photo you can see the layout. The house, again, it's a pretty small footprint, and we have one large room that's a combined kitchen, dining, living, with a central staircase that allowed us to do two rooms upstairs along with a bathroom and a dormer.
So moving from here into another, another common theme within high-performance envelopes is that when you're talking R50 and up, you're just not going to get that with solid wood, and even if you could, you're not going to want to have a big 2x12 thermal bridge, and they don't make 2x16s, and you wouldn't want to be cutting those trees if they did. So how to get to super insulated roof assemblies? Obviously a complex topic. And in many cases, it involves engineered lumber. And Alex and I are both kind of old-fashioned in some ways. Using solid sawn wood really was something we loved. And so I was looking for an engineered lumber alternative that was not using chips from fast-growing hybrid poplar, wasn't coming from down south, was coming from actually solid lumber. I have some concerns over roofs that maybe the chipboard flange is being mistreated by moisture over the long haul. So we really loved the solid sawn option, and we took a floor joist manufacturer from Quebec. It's all North Country spruce, and they're mechanically connected with a finger joint, and then we developed a system to make that into a super insulated roof, which we'll see more about on the next page.
Yeah, so we wanted to get a little more height in the usable space upstairs, so we did a raised heel system on this truss. Ben Brungraber engineered that, so it's got resistance to spread. We also, Eli attached this fabric to the joists, the scissor configuration. That's to aid in insulation, and we'll talk about the insulation system we used in a few minutes.
I'm going to speak a little to this just because you can see that we made ourselves a little manufacturing line that made up all these rafters essentially, and the core structure of this building is actually very simple. It's a ridge beam frame, and you'll notice that one of my workers is standing next to a ridge that's actually inside, and that's one thing that we feel like the timber framer's background gives you a good read on. Even when it's just a simple post and beam like this upstairs, we really felt like there's a great move to be made when you can keep your major structure inside and keep your major insulation outside. And so even though this is a bunch of new materials being tried, it's actually a pretty tried and true structural system.
Yeah, at the bottom of the roof, on the top of the wall there, you can see one of the challenging issues we dealt with in an older frame. And our zip system, the zip sheathing here, is providing the air barrier for the house. And we wanted that to be totally complete and well sealed. But with that frame detail from the original frame, we had to wrap around that. It was a challenge, and I'm sure resulted in some leakiness in the finished house.
You can see here we not only got them up, but as Alex speaks about our resilience, it was really brought home to us. This was, I believe, Hurricane Sandy weekend, and we were racing to get things sealed in, which we did just in time for that. And then as we sat back and watched what many houses had to go through, it was really a validation of what we were trying to do.
So we did something pretty interesting here. It's a little hard to see, but we wanted to provide an airspace, a vented roof system, an airspace under the roof sheathing. And we wanted to do that without adding a second layer of sheathing, which is often done with strapping and then a second redundant layer of sheathing. So we used this weather barrier from Proclima, the Solatex product, that black material, and used it to span between the joists. So it's secured to the top flange of those joists, the rafters, the tri-joists that were used as rafters. So it provides an 1.5 inch airspace. There's caulk there, and then the lath strips that hold it taut and in place.
I'm going to speak a little bit more to this just because I have a lot of roofs out there, and I know nothing's really perfect, and I do get a chance to go back and see what's not working and what is. And for a while we struggled with, are we really ventilating roofs enough? In many cases we weren't. With the old puck vents, we've gone to really full vents and to ridge vents. But then we found that in a place like Vermont where you get wind-driven rain in the summers, and a properly ventilated roof is actually sucking water in on the lee side. And when we see other people doing cardboard roof vent channels or even foam that's not really lapped properly, or putting sheathing, they don't want to spend too much on the sheathing, so that lower sheathing becomes something that's not a really high quality sheathing, and maybe doesn't even get the roof wrap on it because they think their top roof is there. We feel like that's an area that gets wet, and we liked the idea of an interior applied continuous long fabric that had known vapor qualities. It was vapor open, but it was waterproof from the top, and any water that gets sucked in there is really going all the way down and out onto the drainage plane of the walls. So we liked that about it. We liked also that we were able to do it from the inside with the dried-in roof. It still was a challenge and needs some more work, but we also know that even people who have done a full cold roof with 2 layers of sheathing and have gotten full engineering review have really had to think pretty hard about the fact that the sheathing that has insulation on one side and the cold space on the other does have a pretty steep temperature gradient along it. So we feel like this is a good one to look at and to try and develop building science and modeling around.
Yeah, the Proclima Solatex is a product that's distributed in the U.S. by 475 High Performance Building Supply down in Brooklyn, New York. Another challenge we faced, in addition to the cavity fill insulation on the walls, we were going to add exterior rigid insulation, and we'll see that in a minute. But that meant creating window surrounds to extend the openings to the exterior, that 6 inches of exterior insulation can butt up against. Again, with the pre-crafting idea, Eli developed a system to pre-manufacture these window surrounds with splayed openings. They pre-cut all the components, put them together, out of the weather on flat surfaces, and then we're able to pop them into place.
You can see here, I'm going to speak more broadly about some of the big differences in not only doing a deep outboard insulated wall. Of course, everybody who's built anything would say, what are you going to do when you get to the windows? And most North American window manufacturers really have a shipping, it's a flange that they say is for moisture, but now that they're shipping, they start folding them back, and everybody who has handled a lot of North American windows knows the flanges are getting cheaper and cheaper, and the amount of, there's just not, it doesn't make sense to hang them on the outboard of the wall. So when I had done a European window that was jam fastened for the first time, I loved it, but then I had to do a lot of work on the outside. So this being the next generation represents our attempt at a systematic way to make the whole exterior extension jam and put all the solutions into one system.
Yeah, I've written about this system in the Energy Solutions blog that I've posted on Building Green, so you can track that down. Here are the windows in place, and one of our strategies with the house envelope we wanted to demonstrate a couple of things. One, we wanted to, on the north and west sides of the house, show off sort of state-of-the-art windows. And for that, we used quad-glazed Alpen windows with 3 Lowy coatings and Krypton gas fill. So all the bells and whistles, there are 12 center of glass windows, are 8.2 unit values, NFRC rating. But then on the east and south, the parts more visible from the road, where we wanted to preserve the historic character of the house, we decided to go with fairly standard wood double-hung windows. And you see that on the right here. These are Lowy argon, but nothing special. They're not triple glazed. For the energy performance, we're developing and working with Larson, a storm window manufacturer, to put in an advanced low E storm window that will add to that. So we're achieving triple glazing, but in keeping a fairly standard double hung window. And the idea here is that, there are a lot of houses that need deep energy retrofits that have existing windows that are either in pretty good shape or need to be protected for historic reasons. So to go outboard of that with a thicker wall system and a low-E storm window that fits to the outside of that wall system makes a lot of sense.
You can also see one thing on the left here, and I know that people are probably going to want to follow up on more details and actually see the final system as we launch it, which I'm sure will be a topic of a future thing. But we really think of this as a chassis for a bunch of products that would be helpful, with the storms being one, but the ability to do some shading was built into this from the start, and so there's actually a hidden spot in which a roll-down shade could be pulled down in a lot of areas like ours that are borderline for air conditioning, or we want to reduce our air conditioning loads. That solar shading can be a huge factor.
Okay, so here's the window surrounds getting wrapped with more of this Solatex, the Proclima Solatex, and then we used metal sills over the cedar wood that we used for those. Installing windows, we used some tapes, also product made by Proclima, we got from 475. The windows going up, the window surrounds and windows in them, and you can see the house wrap ready for the exterior insulation.
One of our key concepts here or back was that we would have something that would have all the wraps and the drainage and the different house wraps all figured out and done the same way on a bench. And then the siding crew, because we'd like this to be a system that's more broadly available, to have a siding crew who could run whatever the outboard insulation of choice was right to a completely integrated assembly was really our goal here. And we feel like we came a lot further towards it this time, and then we went on from there into a new outboard wall insulation system.
And with this one, again, I wanted to try out some alternatives to foam plastic insulation, avoiding flame retardants. And coincidentally, a couple of months earlier, I'd gotten a visit at Building Green from a company in Portugal that was planning to reintroduce an expanded cork insulation to the North American market. It had been here from around 1900 until the 1950s, but disappeared when inexpensive foam plastic insulation came along. So we were needing rigid insulation for the house, and I thought, well, if I'm not going to try it, who is? So we got hold of some. We had to order it directly from Portugal. Since then, it's now being distributed in the U.S. From the Pacific Northwest, and Eco Supply in New York and Virginia is also carrying it. But it's a rigid cork insulation. Cork is a bark product. It's a bark from an oak tree that grows in the Mediterranean. It's being harvested as it's been harvested for 2,000 years. It can be harvested about every 10 years from these trees. The granules produced from this, after high-quality products like bottle corks for the wine industry, the lower grade stuff is granulized, put into autoclave in these big vats and heated under high temperature and pressure, where it expands and releases natural binder in the cork, in the bark, and holds it together. So the cork insulation is 100% natural material. There's no added adhesive, blowing agent, flame retardant, anything like that. Has excellent flame retardant properties.
Yeah, I'm going to speak to this just briefly here. I mean, we had certainly handled a lot of other outboard insulation systems, and we had timber frame and SIP panel tools, and also some old hand tools that actually worked out really well for this. And all I would say here is that it's actually kind of nice to be using a natural material, and the dust on the ground isn't something that you're worried about. And when people have asked me what did you think about bugs or other things, I would quickly say foam is not perfect that way either. So this was a pretty novel thing.
In addition to using some of Eli's SIP tools from the timber framing industry, structural insulated panel cutting tools, we tried out some old-fashioned hand tools that have a thinner kerf, and found that they work very well for the straight cuts. And with the splayed openings and the sills on these windows, we had to make some pretty complicated cuts. The 6-inch cork we used is lap jointed, so it was kind of tricky figuring out how to install it.
Yeah, you can see that we're just tacking these in place as we go, and it's nice having the lap, and it's nice being totally done with each layer in a brick-laid system. It actually went quite well, but the real fastening happens when the strapping goes on. So this is a heavy load-bearing thing, and the shiplap and having it held on first, and then house wrap, and then from there we went right to a full 1-inch strapping, which I think you'll see in the second one. So that actually has the major screws that are going all the way through, and it's also bearing on the foam glass down below. So structurally we felt like we were not just hanging a facade, but we're actually building it.
So here you see it from a distance, ready for siding. Now, moving back to the interior, we were approached by Knauf that makes fiberglass insulation, and they have this fairly new product called EcoSeal for air sealing gaps and panel joints. And we decided to try some of it. And to tell you the truth, I was fairly skeptical as to whether it would make much of a difference, because we were taping the joints of the zip sheathing on the exterior. So in applying this stuff, which is applied like spray paint basically at the joints, we had Efficiency Vermont come down and do some blower door testing. They were curious about this as well. And much to my surprise, during the course of the air sealing, the air leakage dropped from I think around 900 CFM down to, or 950 CFM down to 640. So a pretty dramatic improvement, which really pleased us. Okay, so that brings us to the cavity fill insulation, the last major element we're going to talk about here. And for that, we debated using cellulose. I've been a huge fan of cellulose for decades. It's high recycled content. It's a waste product made from old newspaper. But we were dealing with pretty thick ceiling cavities. I was worried about the fairly significant weight of cellulose, about 3 pounds per cubic foot. And I also wanted to try out this new product that a number of building science experts had told me about, a product called Spider, made by Johns Manville. It's a spray fiberglass product. And here it is going in at our place. It's sprayed in place. There's a little bit of acrylic binder that's sprayed onto it as it's sprayed into the wall or ceiling cavity. You can spray it in an overhead application. Here we see it going into the 16-inch deep rafters, well, 15 inches up to the airspace. And there's no netting there to hold it in place. With cellulose, you would have had to net that. And this goes in at, I think, 1.4 pounds per cubic foot instead of 3 pounds per cubic foot. The extra material that falls onto the floor gets vacuumed up. On this photo on the left, you can see one workman vacuuming up the excess, and that goes back to the truck and mixed in with the new material being sprayed in. After it's sprayed, they apply this screeding tool to pare it down even with the inside of the studs or rafters. You end up with a very clean look at the end of the day. This was a fairly sizable job. They took the better part of 2 days to install it over a weekend, but came out looking beautifully. It has an R value that's actually a little bit higher than cellulose, R 4.2 per inch. Very good acoustic properties, so we're real pleased with it. On the slope part of the ceiling where we didn't have a good air barrier, again on the walls we have the taped zip sheathing that provides an air barrier. On the ceiling or the roof, we just have that the ventilated air barrier, so we decided to go with this the vapor retarder. And this is another Proclima product, the DB Plus, which is a variable permeability retarder. It basically has high permeability when you want it to be able to breathe, and then lower permeability when times that you want to keep higher humidity out of that cavity system. Getting into just a few finished shots, this is as things are coming together. Eli did a beautiful job on a sort of this corresponding curves on the stairway.
That's not quite finished, I should say, but we should have a separate interiors topic here. I know we're getting close to wrap up, so.
And here we are as it is finished. It's got now some paintings on the wall and stuff, but you can see that corresponding curves. Again, in a future webcast, we'll talk about some of the finished materials we used in the house, the slate, the countertop material, which was a recycled content product. Here you can see the lighting, the LED lighting in the drop ceilings or in the access ceilings. And here is the exterior of the house. This was taken this spring. And a photo showing the house with the barn in the background. Again, in a future webcast, we're going to talk about mechanical systems and the solar electric system. And that's it. So I think we have time for some questions, Tristan.
Yeah, thank you, Alex and Eli. And we do have quite a few questions. I'll try to pick out the juiciest ones. Maybe start with some of the most recent topics, the insulation. Is fiberglass not the asbestos of the future? Was a question we got in the chat. And how did you learn to love fiberglass, Alex?
Well, I've written about insulation materials for a long time, and I've written about the concerns that existed for a while that fiberglass could be carcinogenic. More recent studies have indicated that it is not carcinogenic. It's quite different fiber than asbestos. Nonetheless, I had some misgivings going into it. I've worked a lot with fiberglass in my younger years and really hated it. You'd end up at the end of the day all, itchy, dry throat, very challenging to work with, eyes that stung. So when I went down to that house when they were starting work installing it, I was expecting to see these guys in Tyvek suits and full breathing apparatus and totally self-contained air supply. It wasn't at all the case. They had dust masks, but they were wearing shorts and a t-shirt. And, I spent better part of 2 days in there doing some work with the fiberglass in the little detail areas, and it wasn't at all itchy. It's a very different formulation of fiberglass.
Why didn't you continue the foam glass right up the exterior wall? Why did you switch to cork?
Well, costs, they were both expensive. We spent a lot on both these. The weight was greater on the foam glass, and the R value wasn't as high. The cork insulates to between R 3.6 and 4.0 per inch.
probably a permeability, discussion that I recall too, and that we really love that it can dry to the outside. Foam glass is a pretty impermeable thing, which is great when you're wrapping your foundation in that and drying the foundation to the inside. But I think that was also a factor.
Yeah, if there was a polyiso cyanurate without flame retardants, that would be, the less expensive option. The other option that I think we would have used had the cork not been available would have been Richard Mineral Wool, which I'm also a fan of. And I think that's a great product. There's some new higher density mineral wool products. Did I evade that question well enough?
Nice job, Alex. Well, this question I don't think you can get around. How about the cost per square foot for this project?
Yeah, cost per square foot. It wasn't a budget project. We did some calculations. I think we figured out we're still trying to total up numbers. What did we come up with?
Yeah, mid 200, 250 or so per square foot, which certainly is high for people who are trying to do things on a budget. It's also a small house, so it's driven by that quite a bit. To somebody from Nantucket who is probably spending more than that anyway. I think it's a fair question, but it's also a question, and it's sort of like if you charged everything for the first car that you were building on an assembly line, then that would be really expensive too. And there were many times where we were all spending a lot of time on it, and I know we actually did get some product involved, but we spent way more time and effort, and everybody on it probably put in, everybody, Alex, Geraldine, myself, and my crew all probably put in a little bit more than we wanted at every point. But that's, when it's a project like this and it needs to come out right, that's something we're all proud to have done.
Yeah, we could probably have saved money by simply tearing the house down and starting over. But we wanted to preserve at least some elements of the historic nature of the house. And I've got to say, neighbors stop by, people that have grown up in the area, expressing appreciation all the time that we didn't simply tear it down and build something modern to replace it. Even though 90% of what you're seeing in that house is new, this house still has the character of what was there before, and we really appreciate that.
So what did you guys learn from this? What can each of us give your top lesson learned? What you do differently in the future based on this experience?
You want to go first with that, Alex, or should I give it back?
Take it.
Yeah, I would say that what we learned obviously is that number one, I feel great about the building itself, and I wish I could make those same choices on every building, but obviously we can't. But there are really, what was proven to me right off is that there's a need for the industry as a whole to move from just products to actual systems. And there's so many great companies out there doing good work without really knowing what else is going on or without being truly integrated. And to reach out to them and hear that was needed to take some big steps forward on some systems, and to actually have a number of companies looking to us now saying what's next, that really gives me hope that we're going to drive costs down, we're going to have new paths to get people the great homes they deserve and get all these various good products into integrated systems. So that was the biggest positive take home for me.
Yeah, and I think for me, it's just, tremendous satisfaction that here we have a house that is going to be very low maintenance, very little that'll go wrong with it. It's so well insulated that we can heat it with a 18,000 BTU per hour air source heat pump, a single point source mini split. We'll be able to generate all of the energy the house uses, the all-electric house, all that it uses with the solar system. We have one small wood stove, but otherwise we're all electric. And this winter, which was quite cold, we moved in January and had 3 really cold months. We only used the wood stove maybe a half dozen times to take the chill off when it got down to 10 below outside. So I'm really pleased with not only how it looks, but the functionality and the ease of maintenance, and what we think will be a highly durable house.
We're at our stopping point, but we got so many good questions. I think we're going to take a few more.
That's fine.
Sure, absolutely.
Great. So some questions about the assembly. Why didn't you go with a hot roof or an unvented roof assembly?
Well, I can speak to that a little. I mean, number one, we're definitely in ice dam country here, but number two, we actually do have some areas here in the dormers where we knew we couldn't ventilate out of those valleys. We did do thick insulation on top of the inside. So, I have a lot of roofs out there. I guess generally speaking, our practice has been towards ventilation. I think that that our engineer Mark Rosenbaum really said it well, not on this job but on a previous. When I was asking him that same question, he said, "Well, it's not going to save a bad roof, but it's cheap insurance for a good roof." And when we heard that, and when everything begins at the roof, and we get so much different weather and freeze thaw here, we have moved towards doing it as a matter of practice. But that's our opinion.
I don't know where to even begin if I'm in your shoes trying to answer this question, but what's the advantage of what you did over SIPs, or structural insulated panels?
Well, I'd love to speak to that one if I could.
Go for it.
I mean, I've been in the timber frame and SIP business first, and then moved into basically high performance. I feel great about these buildings in that they have an air barrier. The air barrier is proven and testable, and then things can dry to the inside and outside. That to me feels a lot better than having a really good system like a SIP panel that does have foam joints that don't move in the same way that the rest of the building does. And if there's any problems at those joints, I've seen what can happen. So I feel really great about thick walls with air barriers and with demonstrated drying potential.
Yeah. Back in the 80s, I did the technical writing for Winter Panel Corporation, which was a leading producer of polyurethane core structural insulated panels. And, from talking with installers and the technical team there's some real weak points with SIPs. If the installation isn't done properly, there's potential for moisture migration through those panel joints.
And I should say, actually, in deference to all my good friends in the panel industry, and there are some great ones, if you're considering that home, then it can be a really great system. The installation details at the joints become something that really differentiates a great company from one who's not quite up to it. And so asking those good questions and seeing some things like gaskets and making sure things are cured and making sure that even potentially that there's a warm side seal, those are all things that can make that into a great envelope for sure.
And again, for me, it gets back to the flame retardants that are in all foam insulation today. We wanted to avoid those.
Mm-hmm. What was the siding material?
That was CVG, which is clear vertical grain Western hemlock. It's not as common a siding material as red cedar. We like it for a couple reasons. It has not as many tannins in it as cedar, which can be problematic for house wrap. It's a little more of a sustainably harvested species itself, and it takes paint well, and is available in much longer lengths than most other species.
It's less expensive.
And it's a lot less expensive. Yep. And being vertical grain does mean that it tends to move less with seasonal movement and therefore hold paint better.
We did machine coated had it coated before we installed it, so it was pre-painted.
What was the CAD software that you used that you mentioned at the beginning?
That's a Swiss CAD/CAM software called CADWORK CADWork. It's a small specialty but really functionally powerful software used by the timber frame industry, and was developed in Switzerland 20-something years ago. So they have a big leg up as a dedicated CAD/CAM 3D. there's still some years ahead of, even though there's some great other 3D platforms coming along, that's our platform mostly for the manufacturing side, but we have actually tweaked it to work on the front end.
Did you use any energy modeling software or, heat load calculations?
Mark Rosenbaum did that for us, and he has his own spreadsheets that he's developed over the last several decades. So it's not a particular package. It's just Mark's own spreadsheets for heat loads.
Yeah.
There was a question about the air changes per hour, the air tightness. We ended up at 1.6 air changes per hour at 50 pascals. It's not as low as we were hoping for. It doesn't approach the passive house standard of 0.6 air changes per hour at 50 pascals. But for an existing house, it's not bad. And interestingly, we did a testing mid-construction before the insulation had been installed, and it was also 1.6, and we thought it was going to drop a lot. I think, and this is conjecture, I think that because we did the final testing in really, really cold weather in January, we had some leakages that had opened up due to shrinkage. And I since had that confirmed that, if you do air testing, pressure blower door testing throughout a season, the colder the weather is, the leakier it is as these leakage spots open up. Also, the storm windows weren't installed at that point. In fact, still aren't installed. So I'm hoping that by next winter, with storm windows in place, the air tightness will actually be better.
Can you talk for a second about your sheathing choice, OSB versus plywood versus...
Yeah, zip sheathing is a proven air barrier sheathing. It's made by Huber, and they apply basically a vapor managed paint that's made to bond with a tape that they have. We've been using it for a long time. We've gotten really good results with it, and we've seen it hold up a lot better. It moves around a lot less than a CDX. It would be easier if you could get really great plywood to say, I want to go back to plywood, but we've seen the quality and the sources of CDX get really not that great, and combine that with the fact that Huber is a Maine-based company, and that we know a lot about what resins they're using, and that we know that the product holds up well and can get a really great air seal. It's been our air barrier sheathing of choice for a while now. But we're certainly looking forward to there being more options in that. There actually aren't a lot, and I would certainly welcome future development of a more vapor permeable air barrier sheathing.
Back to the cork, how is that attached to the sheathing?
I think there was one slide there, people look back, where you can see that we were really, since it's lapped and since it's all bearing on the foam glass below, we were tacking it into place through the top lap, much like you would do a hardwood floor vertically. And that was just holding it until it was house wrapped. And then the house wrap is a really stout 1-inch thick native lumber product that we used a long Simpson screw to go through everything with. So that's what's really holding it all.
And I think for our last question, I'm going to put it to you, Alex, about the cork insulation. We had a couple people ask about cork. What if it gets wet? Are there any concerns about insects, things of that nature?
Yeah, I've actually, in Dummerston, Vermont, where I live, I've examined cork that was installed probably in 1920 that's still doing fine. It was even installed under the slab in this apple packing house at Scott Farm in Dummerston. We think it's going to hold up pretty well. Cork does very well in moisture. I mean, that's what we use it for in, it seals wine bottles. The insect resistance, I don't know. I mean, if I had one concern, that might be it, but I think from a defensive mechanism, cork is a bark product of a tree that's designed to protect that tree not only from fire but also from insects. So, I think in engineering new products, we can look to natural systems, so-called biomimicry, and design our own systems that model how nature did it. So that cork bark is a natural fire retardant, fireproofing for the trees. So that's why we didn't need to add a flame retardant to it.
I would add to that having a lot of buildings out there and hearing that same question a lot, I have seen insects run pretty wild in foam, and so I don't feel like that's a great alternative. And one thing that I could say, but we couldn't show it in the pictures here, is because the cork is expanded under really high temperature, it smells like smoke. You can actually that was a way that Native Americans actually protected their seeds from insects. So I would not be surprised if there really was, if I were to have to bet, I would bet this is going to be way more insect-free than a foam alternative.
The other question with cork is, how can you justify bringing a product over from Portugal to install in a house in Vermont? And that's a fair question. We did some pretty careful looking into the carbon balance of this cork insulation, and according to the manufacturer and a life cycle assessment that they did, even with the shipping energy taken into account, this cork is a carbon positive product in that growing the cork trees and adding organic matter through the roots of the cork tree and so forth sequesters more carbon than is expended in shipping it here. So we feel pretty good about it from that standpoint.
I'm going to actually say one more thing. Even if I never get to use cork again, there's a broader general trend that I see a question about in that going outboard with thick insulation is a challenge. It takes there's a lot of different options, cork being one, but the point I think that I feel great about and that where building science for these type of buildings is going is when you're starting to trust an air barrier and tape and you really want that to last, then I feel like in the northern climates you need to really keep it warm, and I feel good about having a thick enough insulation layer. I've seen some products out there that are thin and they're not permeable. I worry more about those than I worry about this one, and I feel like it's a challenge to continue to be solved. There's going to be a lot of different alternatives for that, but outboard insulation is a great topic because it's something that gives us the promise to being able to retrofit a lot of houses, and so I feel really good about that.
Okay, thank you very much. We've been listening to Eli Gould of Ironwood Brand and Alex Wilson, founder of Building Green. My name is Tristan Roberts of Building Green. Thank you very much for attending today, and we'll see you on a future Building Green webcast.
Thank you much.
Thanks for the great questions.